When working with exponents, it can seem like it's just a bunch of rules to memorize and that it doesn't have any meaning, but it really does if you take the time to think about what each problem is saying. I'm not going to go through each problem this way, but I do want to make sure that you understand where the rules come from. So for number 1, 4 to the 8th is literally 4 8 times, or 8 fours, and then an additional 10 fours for a total of 18 fours. And I got really sloppy there, but 8 fours and then 10 more fours is 18 fours altogether. And so that's 4 to the 18th power, and then that rule is when multiplying powers with the same base, add the exponents. Since the fours are the same, you can add the 8 and the 4. Okay, jumping over to number 3, 4 to the 7th, so 1, 2, 3, 4, 5, 6, 7 fours. And in the denominator, 1, 2, 3, 4, 5. Well, if you start canceling out those common fours, 4 divided by 4 is 1, and you're left with 2 fours in the numerator. So the answer is 4 squared, or 16, if it asks you to simplify. But that rule is when dividing powers with the same base, subtract the exponents. 7 minus 5 is 2. And actually, looking at that now, if you saw that as a 3, right here for 4 to the 3rd power, you would have 4 to the 3rd over 4 to the 5th. In this case, 1, 2, 3 fours on top, and 4, 4, 4, 4, 4, 5 fours in the denominator. And when you cancel them out, you get those 2 fours in the denominator. Again, this is if you saw question 3 written this way and not the other way. So we have 1 over 4 squared, or 1 over 16. But if we use the rule, 3 minus 5 is negative 2, and 4 to the negative 2 becomes 1 over 4 to the positive 2. And again, I like to use the rule that negative exponents move and become positive. So 4 to the negative 2 moves to the denominator and becomes positive. So one more here, 2x to the 7th to the 3rd power really means 2x to the 7th, 2x to the 7th times 2x to the 7th. And if we wrote that out and regrouped, we'd have 2 times 2 times 2, which is 8. And then we have 7 x's, 7 more x's, and 7 more x's for a total of x to the 21st. The rule to remember is that when you take a power to a power, you can multiply the exponents. Okay, so when taking a power to a power, so wanting to group those together, when I say x to the 7th to the 3rd, it's actually x to the 21st. And then 2 to the 3rd, we know is not 2 times 3, it's 2 times 2 times 2, which is 8. So the answer to number 8 is 8x to the 21st. Hopefully going over those couple of problems and showing the reason why those rules work help you. But as you do more problems and you get quicker at these, you do want to rely on those rules to help you out. But just remember that they came from somewhere. They're not just some made-up rules to make math really confusing for you as a student. So back to the problems here. Number 1, it is 4 to the 18th, and if the directions said to write your answer as a single exponent, that would be the correct answer. And if it does say simplify, you'd want to take 4 to the 18th power. Hopefully you have access to a calculator and you could write that out. So just moving on, number 2, we are multiplying powers with the same base, so we're going to add the exponents. 1t plus 3t is 4t, so the answer to number 2 is 7 to the 4t power. For number 4, we have the same base, so we're going to add the exponents. 2 plus 4 is 6, so we have negative 9 parentheses to the 6th power. For number 5, we have dividing powers with the same base, so we're going to subtract the exponents. So 3x minus 1x is 2x, so we have 2 to the 2x power. For number 6, we also have dividing with the same base, so we're going to subtract the exponents. In the denominator, we have the first power, so 10 minus 1 is 9, so we have negative 654 to the 9th power. For number 7, we have powers to a power. So when we take a power to a power, we multiply the exponent. So we're going to take 4 times 7 and get a to the 28th. For number 9, we have everything to the negative 1 power, and negative exponents move, negative exponents move and become positive. So sorry about that, I'm trying to get this one bigger. Negative exponents move and become positive. So this all is going to move to the denominator and become 4c to the positive 1 power. I'm not going to put that there because that's implied, but I do need a 1 in the numerator. So 1 over 4c is the answer to number 9. Just as a side note here, these are some possible answers that I would see on a test. I could see something like negative 4c as an answer, which is not correct, somehow thinking that that negative 1 gets multiplied by the 4, and that's not right. I might also see something like 1 over 4c to the first power, or the negative 1 power, and that's not right, because once the exponent moves, it becomes positive. So sometimes thinking through some wrong answers helps you study for what the right answers are. All right, for number 10, anything to the 0 power is 1. Again, that's not some made-up rule. There's a pattern that exists when you're working with exponents, and the 0 power does make an answer 1. However, there is that negative there, so it's a negative 1. A very common answer on this problem would be 0, but the 0 is not the right answer. It's negative 1 in this case. For number 11, we have w to the 3rd to the 7th, or w to the 21st, and x to the 5th to the 7th, or x to the 35th. For number 12, we have 3 squared, which is 9, times 10 to the 5th squared, which would be 10 to the 10th power. For number 13, we're going to move that to the denominator and make it 8 to the positive 2 power, putting a 1 in the numerator. So simplified, that would be 1/64. And for number 14, we have a negative here, but don't let that confuse you. Just take that out for a second. We have negative 1 times x to the negative 3, x to the 7th, which would be x to the positive 4, because when you multiply with the same base, add the exponents. Negative 3 plus 7 is 4. And then we're multiplying it times 3, and then x to the negative 9th. Everything's being multiplied here, so we can have some rearranging here. Negative 3 times the negative 1 is a positive 3. And now we have x to the negative 9th and x to the 4th, which is x to the negative 5. Well, negative exponents move and become positive, so I'm going to put a fraction bar and put x to the positive 5 on top there. So let me pause the video and rewrite that so you can get the correct answer. Okay, for number 14 then, we have 3 over x to the 5th. And we got that by taking negative 3 plus 7, which is 4, 4 plus negative 9, which is negative 5. That's why x to the 5th is in the denominator. And then I regrouped using the associative property, negative 1 times negative 3, and got a positive 3, which is in the numerator. For number 15, I like to just start by writing my fraction bar, so I know that I have a numerator and denominator. Some things are going to end up in the numerator, some things in the denominator. If I take just the b's, same base, so I'm going to subtract the exponents. 3 minus a negative 2 is a positive 5, so b to the 5th is going to end up in the numerator. For the r's, we have r to the 7th, r to the 6th, so the r's, actually only one r is going to be in the numerator. And then we have p to the first over p to the third. Well, 1 minus 3 is negative 2, so we're going to have p to the positive 2 in the denominator. B to the fifth, r over p to the second. On number 16, if we regroup using our associative property, we can group things together. We have 5, 3, and negative 4 that we can put together and make negative 60. And then we have x, x, and x. We have x to the n, x to the 2n, and x to the fifth. Well, n and 2n can be 3n, so we can put x to the 3n, and then the plus 5 can just be written just like that. The answer is negative 60x to the 3n plus 5 power. Now, I had some students write x to the 3n and then x to the fifth separately, but because these have the same base, we can add the exponents. Now the exponent in this case is going to be just an expression, 3n plus 5, but you can write that as one expression versus separating it out because they both have the same base. Finally, number 17, we're going to take 3 to the negative third power, t to the negative fourth to the negative third power, and w to the negative third power there. So let me erase my lines so I can see those. But again, I'm going to start by writing my fraction bar because that helps me remember what's going to stay in the numerator, what's going to stay in the denominator. So first of all, I have 3 to the negative third power, which moves to the bottom and becomes 3 to the positive third power, which is 27. We have t to the negative fourth to the negative third, which is t to the positive 12, so that's up top. And then w squared to the negative third is w to the negative 6, which moves down to the denominator and becomes w to the positive 6. So we have t to the 12th over 27 w to the 6th. For number 19 through 24, we're writing in scientific notation or standard notation. Remember that that first number has to be greater than or equal to 1, but less than 10, and that your exponent on the 10 can be positive or negative. For number 19, we have 4 times 10 to the fifth. For number 20, the decimal on 4 is right here, so if we move it back 3 places, we have 0.004. On number 21, we have 3 times 10 to the 1, 2, 3, negative third power. And on number 22, we have to move it over 1, 2, 3, 4, 5. So we have 4 zeros to add there, and then a comma, 150,000. For number 23, we have 1.901, and we'd have to move it over 1, 2, 3, 4, 5, 6, 7 places. 10 to the 7th power. And for number 24, if the decimal is right there after the 8, we're going to add 6 zeros and get 8 million for our answer. For number 25, if I multiply 8 times 2.5, I get 20 times 10 to the negative 2 plus negative 7 is negative 9. But I do have to make that 20 into a number greater than 1 but less than 10, greater than or equal to 1 and less than 10. So I'll do 2.0 times 10 to the negative 8th. Don't forget to change that exponent if you change that first number. And then finally, when I take 1.55 divided by 3, I get 0.516 repeating. And so I might just round that to 0.517. You might see either one. And then because we have to make that 5.16, we've got to move it over one place to make it greater than or equal to 1 but less than 10. It's going to either be 5.16 repeating times 10 to the negative 7th, or if you rounded 5.17 times 10 to the negative 7th. That's it for Chapter 7. Hopefully you did well. If there's anything you need to review more on, just make a mark and make sure to ask about it in class.